Today we are going to look at density. Density is a key concept in chemistry. I'm sure many of you have probably heard of it before, but we're going to get into a little more detail with density today. So starting off, we're just going to define density. What is density? Density essentially represents how compact, keyword, how compact a substance is. A common word often used instead of density, if you wanted to give it a synonym, would be compactness. So the compactness of a substance. You've probably picked up two substances before that appear to be the same size, but one seems to have a much higher mass than the other. That's typically because it is much more dense than the other object, and that's something that we're going to explore as we explore density. Now, density, there is an equation that we use for density, and this equation is exceptionally important. I'm going to bold it. Density, I'll write it all out. Density equals mass divided by volume. So the equation you'll typically see is D equals M divided by V, just like that. Density equals mass divided by volume. Now, a few things you need to know. Density is measured in grams per milliliter. The reason it's measured in grams per milliliter is because mass is measured in grams and volume is measured in milliliters. So that's how we end up with density. We have density, we have grams of mass, we're dividing that by milliliters of volume, and that's how we end up with density being measured in grams per milliliter. Now there is one exception to the rule. Volume can also be measured in centimeters cubed. Now that 3 should be up here, but we're unable to do that on the smartboard. So the 3 should be right there. I'll just draw it in there for the sake of you being able to see it. So it should be centimeters cubed, just like that with a little 3 on top, which means density could also be measured in grams per milliliter or grams per centimeter cubed, whichever unit of volume is used in the problem you are approaching. That will determine which density you use, either grams per milliliter or grams per centimeter cubed. Now, something you should know, it's essentially the exact same thing because milliliters equals centimeters cubed. So 1 milliliter is equal to 1 centimeter cubed. So no need to get that confused at all. So that is the basics of density. Now, one thing I want to show you is something we call the density triangle. And this is something that will help you an immense amount as you are solving density equation problems. So you draw your density triangle just like this. You have density with a D in the lower left-hand corner. You have mass with an M on the top and volume with a V on the bottom. So how you use the density triangle is when you are given a problem, you will always be given 2 values, and you'll see we're going to do practice problems here in just a minute. You'll always be given 2 values. You put those 2 values wherever they should be located in the density triangle. For example, if you're given 20 grams, you would put that up here where mass goes. If you were given 20 liters, you'd put that down here where volume goes. And what it does for you is it allows you to see how to solve for the unknown variable. For example, if we were solving for density and we were given a value for mass and for volume, we would know that mass needs to be divided by volume because mass is above volume in the density triangle. If we were given density and volume and we didn't know mass, then we would know that density is multiplied by volume to solve for mass because density and volume are next to each other. That's something that we will explore as we go into practice problems. So make sure you have down our basics of density here, and you'll see how this density triangle works once we do some practice problems here coming up right now. So these are 3 density practice problems. What we've done for you here is I've shown you what your unknown variable is, and so that is what you are solving for. Wherever the question mark is, that is what you are going to be solving for. So I'm going to start off by just drawing the density triangle over here so you can remember what it looks like so we can continually use it throughout. So we got the density triangle. My smartboard drawing skills aren't perfect, but bear with me. So density, mass, volume. So how the density triangle would work. We don't know density, but we do know mass and we do know volume. So you would draw the density triangle right here. Okay, so we don't know density, so we're going to put D right here because we do not know what density is. Do we know our mass? Yes, we do. Our mass is 19, so we're going to put 19 right there. We also know our volume, which is 27, so we're going to put 27 right here. And look at that. We are ready to go. Now what you see here is to solve for density, 19 is over 27. That means you have to do, it's like a fraction. You have to do 19 divided by 27. So I take out my handy dandy calculator, do 19 divided by 27, and I end up with an answer of 0.70. So my answer would be 0.70. And all I did was 19 divided by 27, got that by plugging my 19 in where mass goes and my 27 in where volume goes. Now don't forget your unit of measurement, which our unit of measurement for density, if you look back at your earlier notes, is grams per milliliter. So that is our answer to our first question right there, is 0.7 grams per milliliter. Now you can always go ahead and try these ahead of me and then check your answers. That is up to you whether you are feeling confident or not. Okay, we'll go on to number 2. We have our density is 12 grams per milliliter. We don't know our mass, and we know our volume is 21 milliliters. So let's draw our density triangle right here. What a perfect triangle that is. Drawing the density triangle. Okay, density goes down here. We know our density this time. It's 12, so I'm going to put 12 down there where density goes. We also know our volume, so 21 milliliters. So I'm going to put 21 down here where volume goes, and we do not know our mass. Now, what this is showing you, to solve for mass, you have to do 12 multiplied by 21. You can even draw a little X here in your density triangle if that helps. Anytime numbers are next to each other, you multiply. Anytime they're vertical with each other, you do top divided by bottom. So like here, we had to do 19 divided by 27. Here, we're doing 12 multiplied by 21. And that's going to give us our answer for mass. That's really straightforward, right? Not too bad at all. So 12 multiplied by 21 is going to give us 252. Whoops. There we go. 252. And it's mass, so our mass is going to be measured in what unit? Grams. Mass is going to be measured in grams. So 252 grams is our mass. So far, so good. Let's do one more practice problem. Again, you can jump ahead and do this ahead of me if you would like. Okay, first thing we always do is draw our density triangle right there. And I have the reference for you up here. So we're given our density. So we put density always in the same place, the lower left-hand corner. It's 28.4. Like I said, not perfect with the smartboard, but it's good enough. Our mass is 14.2. 14.2. And we do not know our volume. So we have now solved for every single one of these. We did density here, mass here, and volume here. Now, like I said just a minute ago, if they are vertical from each other, you need to do the top divided by the bottom. That means here you need to do 14.2 divided by 28.4, and that is going to give us our volume. So it's really, these are all just one-step problems. So 14.2 divided by 28.4, and that is going to give us an answer of 0.5. And what is volume measured in? Milliliters. I get that from right here, milliliters. Milliliters. Whoops, there we go. No worries, we're good. Milliliters, right there. And so that is our answer. So those are 3 pretty straightforward practice density problems. The next density video is just going to be 3 practice word problems. And those you're going to solve yourself. So get ready for that. If you have questions about density, of course, ask. But there we go. Good luck and farewell.